Okay. You can hear me, right? Hello, everyone. Thank you for joining the session today. My name is Fabian Alves. I'm a product manager in identity and network access. And I've been working in external ID for the last 3 years. As you notice, I'm not a native English speaker. So if you see me freeze, it's nothing wrong. I'm just, processing Spanish in my brain and speaking English, okay? So let's start with the presentation. So basically, we are going to talk a little bit about the opportunity we have about infusing AI into our applications, the challenges around identity. I'm going to show you a demo of an AI agent in the context of a consumer scenario using external ID. And of course, we're going to review the code and see a couple of takeaways. So you've already seen the keynotes and a lot of sessions before this one. And you know that there is a really high adoption rate of generative AI in all the organizations and all the applications. So I think it's a great opportunity we have at the moment to infuse AI in our applications. Also, building agents is easier every day. Now we have Azure AI Foundry, right? We have a set of SDKs. MCP protocol is also the new cool thing that we have and you can use. This presentation and this demo is using a C# SDK for Azure OpenAI, but the concepts around identity are basically the same. So I'm going to focus specifically on the challenges and how to integrate an agent, focusing on the identity aspects of it. And of course, AI boosts a lot of productivity, but it introduces new risks. And there was a survey done by Microsoft a couple of months ago, where almost 60% of organizations expect a rise of security incidents related to the generative AI usage. Okay. So why should you care, right? Because it's really important that you prepare your applications for scale with AI. Okay. There is, as I mentioned, there is a big opportunity. We have a lot of tools, a lot of services in the platform. And of course, if you do it and you implement the right identity architecture, you're going to see fewer critical production errors, and you're going to be able to focus more on new features and improving your application. So I've been playing around with agentic scenarios since the hackathon in 2023, and I found that several people, even in our teams, were struggling to get the identity portion right. It's not easy sometimes. There are challenges related to what authentication flow to use, how to implement role-based authentication. And of course, in the consumer scenario, we need to balance the friction and the security, right? So in the demo, we are going to see how we can handle all these challenges and also adhering to the zero trust principles, right? And of course, for this demo, we are going to use Entra External ID, which is our newest SIAM product, which is focused on be fully customizable, right? You can control the user experience completely, and also is secure and scalable. You can scale up to millions of accounts, okay? So enough with the slides. Let's go to the demo. But before going to the demo, I'm going to show you a little bit of the architecture so you can understand what is going on in the demo, right? So basically, what you're going to see is a user using a browser, right, accessing a web application. In this case, I'm using a web application that is the official demo for Entra External Identities, the 𝗦𝗲𝗀𝗀𝗶ecie application. This web application is secured by Entra External ID. So when the user authenticates, it will be redirected to Entra External ID to do the sign-up process. After the user signs up or signs in, it will access the agent API, which is another application registration in Entra. This agent API is responsible for implementing the agent and is using Azure AI Foundry at the moment with 𝗦𝗽𝗲𝗸𝗀𝗀𝗀𝗀𝗀𝗀 as a model. And this agent API will act as an orchestrator to call APIs in the resource API, which is the one that has access to the database. And you're going to see the demo is around a shopping cart. So basically, the resource API is the one responsible for handling the products, the carts, the checkout process, etc. So I'm going to switch to my laptop and kick off the demo. So what you see here is, this is a live demo, right? So it can go wrong, hopefully not, but this is a live demo. So I have here in the left portion of the screen the web application, which is the 𝗦𝗲𝗀𝗀𝗶ecie application, okay, which is basically a grocery store. And in the right portion of the screen, at the top, we are going to see the telemetry in real time of the token validations done in the resource API. In the bottom right of the screen, we're going to see the telemetry of the agent orchestrating all the API calls to the resource API, okay? So let me kick off the demo, and hopefully we can see it a little bit. So I'm going to start by creating a new account. I have already prepared an account in Outlook, okay, for this. So I'm going to create a user. And now at the moment, I'm using email OTP as part of the sign-up process. This is one of the ways that we have in external identities at the moment to verify the identity. So I got this email with the code. I'm going to copy the code to kick off the sign-up process. And here you can see, of course, you can see that the UX is configured to match the application look and feel, right? So I'm going to set my credentials. But besides that, if you see here, we are collecting three pieces of information that are relevant for the demo: the date of birth, dietary restrictions, and display name. So for the date of birth, intentionally, I'm going to choose a relatively young user, okay? So I'm going to simulate a young user, a minor, you know, using the date of birth. For dietary restrictions, I'm going to use X, and let's choose Luca as a display name. So that portion of the flow was done in Entra External Identities. Now we are back in the application. And if you can see here, let me make it a little bit smaller. You can see here the application already knows who I am because it got the tokens. So I'm going to go to the agent implementation and make it a little bit bigger. Okay? And then to kick off the demo, I'm going to ask the agent to help me prepare a meal. Can you help me prepare a meal? And of course, this is using 𝗦𝗽𝗲𝗸𝗶𝗶ecie Mini, so it's already trained and it will come up with a set of recipes. I'm going to talk about later about this YAML file because it's important. But here you can see that the agent already knows who I am, okay? And also the agent knows that I have a dietary restriction. So I think I'm going to ask him, I want to prepare some tacos. Okay? So if you see here, since you have a dietary restriction, so it knows that I have this a dietary restriction because this information is included in the token. So let me show you the token. So I'm going to use the shot.ms application, and this will show me the content of the token. And if you see here at the bottom of the token, we had the information that we collected during sign up, okay? So that is why the agent knows about who I am, the age, and the restrictions. So it's proposing me to gather a recipe. Okay, I'm going to say yes. And you're going to start to see here in the telemetry that is starting to generate requests to the resource API, okay? And it's proposing also a recipe. It's a little bit slow, but. So once it proposes a recipe, it will offer me to add those products to the cart. It's never so slow, so I think it's because we are doing a live demo. Anyway, we need to wait until it finishes. So you get the idea, right? The agent is acting as an orchestrator to call these APIs, okay? Okay. Okay. Again. Okay. Type of meal. The good thing of working with AI is like you can debug, it's like doing brain surgery on, on the thing. So, I don't know, some Greek food. So if this doesn't work, I still have another way to show it, okay? So let's try some Greek food. Okay, so if you see here, would you like me to add any of these products to your shopping cart? I'm going to say yes. And hopefully you will start seeing here a set of post operations. Any available product. You're going to start to see here some post operations. And at the top right of the screen, you can see the tokens, the claims inside the tokens in the resource API, okay? So it seems that it's working now. It's important to notice that in order to adhere to zero trust principles, specifically the verify explicitly principle, we need to have the information in all the layers, in all the APIs of the application. So that is why I'm showing here the claims, okay? So now we have some items in the cart. I'm going to try one more thing of Pinot Noir, which is a wine that I know I have in the database. So if everything goes well, the agent is going to tell me, since you're 10 years old, I'm unable to add an alcoholic beverage. So this is some kind of age gating, you know, based on the information of the user. So let me try another thing. Please add 10 bags of saffron. And this is because I know saffron here is expensive, and I want to get the cart up to more than $100, right? Because we want to trigger a step-up verification and a step-up identity verification. Okay, so we have now a cart of $500, okay, which is a lot, but let's go to checkout. And if you see here, there is one claim called ACRS. This claim is the one used to know if the user did complete the MFA challenge. So I'm going to say, OK, checkout. So the agent is telling me, since your cart value is more than 100, please verify your identity. And when I click here on this link, this dialog is part of the web application, OK? So this is implemented in the web app. But when I click here on continue with verification, I will be redirected to external ID. I need to authenticate again. And since this is the first time, because this is a new account, I can choose what MFA method I want to use. In this case, I'm going to use email, OK? So this is going to send a new email with the code. I'm going to copy the code, share it here. I want to stay signed in, sure. So I did verify my identity. Please check out. OK, so now if you see here, there is one. Now the claim ACRS is coming with a value because I did complete the MFA challenge, OK? So there may be some issue with the prompt that is saying that I have an alcoholic beverage, but never mind. The important thing is that the identity portion is it's working, right? It's not allowing me to buy alcohol and also trigger the MFA mechanism. So this is one part of the demo. Let me show you another portion of the demo for which I need to use a different account. So now I'm going to sign in with an administrator account, this one. And this account has an application role configured. So if I say hi, the agent should tell me that I'm a product manager and I can do CRUD operations in the application. See? So since you are a product manager role, okay, I can assist you with CRUD operations. So okay, increase the price of avocados 25%. I don't know. So you'll see here, it's going to search for the product avocados, and it's going to do a patch to the product to increase the price. Okay? So basically, what I've shown in the demo is that you can use the information in the tokens in the agent to know who the user is, include age gating mechanisms. I show you how that you can do a step-up authenticate, step-up MFA for high value transactions, and also the usage of application roles. Those three features are features of external identities integrated, in this case, in the, with Azure AI Foundry and you know, the agent API. Okay, so basically this is the demo. Let me switch back to the presentation, and then we can see a little bit more of how this is working, right? So let me go quickly through the authentication flow so you can understand what happened through the demo, okay? First thing, the user authenticates, go to the web app. Step number 1 is not authenticated, so it's redirected to, I don't know if I can point here. Do you see the mouse? Yep. Okay. So in point number 2, the user is redirected to Entra. In this case, I did the sign up process, but it's the same if you sign in. You get a set of tokens back to the application, an identity token and an access token. Then the browser presents those tokens to the web application. The web application performs the validation of those tokens, okay? And then, in this case, the chat UX is implemented in JavaScript in the browser. So the browser directly connects to the agent API here by sending an access token with the with one scope that I'm going to show later, but it's basically the user and the browser has only one access token with the scope to consume this agent API, okay? So the agent API receives the token, and then it uses the on behalf of flow, which allows to exchange the original token for a new token with the scopes to consume the resource API. So in this way, the user can never access the resource API directly. They need to go through the agent, okay? And then, of course, the resource API receives those tokens, validates the tokens against Entra, and then the resource API can perform the validations needed in the use case, right, using the claims. So this is basically what happened through the demo, okay? So in terms of what I did in how I configured this in external identities, basically I created 3 applications, one representing the web application, one representing the agent API, and a third one representing the resource API. In all those cases, these are confidential client, which means they are applications that can store a secret, okay? You could implement the web application as a single-page application, and in that case, it would be a public client. This can be done. And for the web application, we are using the outcode flow with delegated permissions, and we are triggering the MFA. The agent API is using the on behalf of flow to exchange the tokens. It's also using delegated permissions. We are using, I'm going to share the, at the end of the presentation, I'm going to share the link to the repo so you can see the code. We are using the default scope in order to facilitate let's say if you add new APIs in your resource API, then you don't need to change the agent because you're already asking for all the scopes consented for the application. And of course, to reduce the friction generated to the user, we are doing an admin consent directly to those permissions. So let me switch back to my other computer and show you how this looks in Entra External ID. Oops, sorry. So if you see here, I have 3 app registrations. Let's start with the resource API. In this case, it's called Goodgrove APIs. This is a confidential client, so we have a secret here. Or no. OK. I thought we had a secret. No. This is because this application is only exposing the APIs. So this is the resource API. And if you see here, I'm exposing a set of scopes. And this is important to adhere to the zero trust principles, right? To have granular scopes. In this case, we have a scope for products write, products read, cards read, cards write, and checkout process, OK? So, and also to implement the application roles and the airbag, we have an application role created in all the applications, OK? And one more thing to mention is that in the token configuration, you see here I'm adding the ACRS claim, which is used to see if the user completed the MFA challenge, OK? So this is the app registration for the resource API. Let's check the agent API, the one in the middle, OK? So this agent API also exposes an API with a different scope, chat.use. This scope is going to be used by the web application to talk to the agent. And of course, the agent has permissions to all the scopes in the resource API. And I did grant admin consent to reduce the friction to the user. Of course, if you implement, if you implement this in a workforce tenant and you want to do the incremental consent, that thing is supported also in the MSAL library. You can do it. So basically, the agent API exposes an API and also has permission to consume APIs in the resource API. And in the same way, we have a configuration for the ACRS claim. And let me show you another thing. We need to go here, click here, and click on single sign-on. And you will see here that there is a configuration to include these claims in the token, OK? So this is the way that we tell Entra External ID to include the claims in the token for all these layers. And the last one is the web application, which in this case is really simple. This one has a secret, OK? It's a confidential client. The agent API also is a confidential client. And this web application has 2 permissions. One for the chat.use, which is the agent API permission, and the permission to read the user profile, OK? So let me go back to the presentation. So how this architecture or this configuration adheres to the zero trust principles, and what are those principles? So the first zero trust principle is use the least privileged access, OK? The way to achieve that is to use granular OAuth scopes. So at least you need to have one read scope and one write scope, right? So if you have at least 2 levels of read and write scopes, at least it's a good place to start. Okay. We are also using delegated permissions, not application permissions. So the main difference is that delegated permissions are scoped to the user. Application permissions may have tenant-wide impact. So by using delegated permission, we are adhering to this least privileged access. And of course, we are using RBAC to control who can access the information. The second principle is verify explicitly. So I can't show you everything now in this demo, but you will get access to the code, and you will see that we are validating tokens in all the layers. We are using claims to enforce business rules. And also, we have an explicit authorization attributes in the code. And we are using MFA to verify the identity. And the third principle is that we need to assume breach. And if you notice in the previous diagrams, I never put any kind of network separation between the APIs, right? That is intentionally because we need to assume breach, right? So we need to consider that maybe a user can get access to the resource API directly. So the security needs to be part of the identity, right? So by assuming breach, what we did to adhere to this principle is first to use telemetry in all the applications. I mean the code is also providing metrics for token validation. So if it sees a lot of token failures, it will, you will be able to see it. We are logging a lot of information in the code and sending proper error responses to avoid oversharing, information in the error response. Okay, so let's see the code, which I think is a most interesting part. So I was planning to show the code here in the PowerPoint presentation, but I think it's going to be better if I show it here in the live Visual Studio Code. So give me 1 second. I'm going to make this bigger. This one. OK. So the first thing to say, this is really, really interesting. The way I started to develop this application was asking Copilot to create a YAML, an OpenAPI YAML file for a shopping cart scenario. So this was the starting point, right? After I got this file from Copilot, I used GitHub Copilot here, and I told it, OK, you have the definition of the APIs. Please build me all the controllers and all the models. So everything here was built by GitHub Copilot automatically. It took about 20 minutes, and I had to do a couple of clicks. But it was really amazing, to build all the backend with entity framework in memory and all the, is it big enough? OK. Let me make it a little bit bigger. So if you see, this YAML file contains all the definitions of the endpoints in the API. So basically, it's a standard way to describe an API. Okay. So I use this as a base to create the code, but also I'm using the same file here in the agent. So I don't know if you noticed, but when I started the agent here, if you see this line, so basically the agent is loading this YAML file into a vector database. And this is the way that the agent knows how to call the APIs, okay? This is the way that it learns about what are the APIs available, how to call them. So I think this is also a really nice way to implement this kind of agents. So also it's a great opportunity for brownfield applications. So if your application are already using APIs and you adhere to the OData standard, should be really easy to implement an agent to use your APIs. Okay. Let me show you a little bit here of just to give you an idea of the complexity of the system prompt. All the agents use a system prompt which defines how the agent should behave, okay? So, and the main idea of these, new reasoning models, and specifically the agents that we can create now, is the ability to use tools, okay? So, particularly in this case, I created a couple of tools that allows us to integrate with Entra external identities. They are really simple. So the first thing is every time the user receives a message from the user, call the tool get user info name, get user info function name. So basically this tool will read the contents of the token and provide the claims to the agent, okay? So this is the way that we provide the agent a tool to know who the user is. Then let me go to the second here, this one. If you see here, I'm telling the agent that the agent needs to use the OData queries. And this is another tool, the custom API function name. And this tool is basically the one that enables the agent to do the HTTP requests using the right tokens. And this is the tool that implements the on behalf of flow. Okay, so we also have a combination of tools. Sorry, I don't know what's happening. Okay. So we have a combination of tools here also saying, okay, get the date of birth from the claims in the token. Use, this is another tool, a really dumb tool, which basically gets the system time. And using that information, calculate the user age, okay? This is the way. And of course, this is not only controlled in the agent. This is also controlled in the resource API, okay? So in the checkout process, in the resource API, we are also controlling that the user is not a minor, okay? So you get the idea, right? In the system prompt, you define how the agent should behave. And with certain tools, we can enable the integration with Entra. Let me go to this one, checkout and MFA verification. So if you see here, oops, sorry. Every time the user asks to check out, verify if the total card exceeds 100%. And then I'm telling check if the user has a claim called ACRS with the value of C1, okay? So this is a way that the agent can check if the user did comply with the MFA challenge, okay? So basically this is let me show you one more thing. I think I mentioned this before. But if you see here, I'm telling the API documentation is provided in the OpenAPI Swagger YAML format, and use the file search function name tool to understand the APIs, basically. And I'm doing a little bit of fine-tuning here because we have not only the OData query, but we have an endpoint for search. So I'm telling the agent, for search, use the search API, and don't try to use the OData filter because it's not, the best way to do it. So this is basically the system prompt and the tools. Let me go back to the presentation, and we can see the tools here in more detail. So this is the first tool, right? It's really easy to, because this basically will receive, of course, you need to get the token to the agent, right? But once you get the access token to the agent, it's really easy to read the information of the token and present that information as a JSON to the agent, okay? So this is a tool that allows the agent to read the tokens from the claim. This second tool is basically the custom API function name, which basically enables the agent to call an API. And if you see here, we are asking for the method, get, post, patch, put, etc., the URI, the body, and the scopes to call the API. So basically, we are telling the agent or the LLM, we need this information, we need you to produce this information in order to call the API, okay? And we already seen this user personalization in the code. So I'm going to move a little bit faster here. We already seen the API documentation. Let me go directly to this one, okay? So in the resource API, we have means to validate if the user completed with the MFA challenge by also inspecting the claims in the token, okay? So we are not only validating in the agent, but also in the resource API. And also, for example, we are using this required app role here that basically tells that in order to create a product, you need to have the product manager application role, okay? So this is to show you that we are verifying explicitly in all the layers, okay? Again, the MFA validation. And as I mentioned before, you can check the code. The repository is public. Yeah. So basically, hopefully, I was able to demo how you can create an agent and integrate it with Entra External Identity using a set of tools, leveraging the reasoning models, and the function calling capabilities of these new models. So key takeaways. I think we are in a moment where we have a great opportunity to infuse AI in our applications, right? But we need to do it in the right way with the right identity architecture, and there is also an opportunity to learn from Microsoft Secure Future Initiative. I don't know if you're aware, but we publish the SFI report, I think like every 2 or 3 months. This is a really good way to learn how a large organization like Microsoft is implementing zero trust. So I really recommend that you follow the reports, read what we are doing, so you can learn from our implementation of zero trust at Microsoft. And of course, follow the zero trust principles when you are building your application, okay? So I think we are at the end of the presentation. This is the link to the repository. You know, there are no links for SFI, but for sure you will be able to find it. This is the demo. This is the presentation we can open for QA. We can review more code if you want, so I'm open to any question. If you want to ask a question, please use the mic so it gets recorded, okay?
Hi, thanks for the presentation. It's very good. Does External ID support offline mode?
Offline mode?
Yeah, so if I want to have a user log into the application and I'm going to have this agent go and work for the next 3 days, how long does that token stay alive for?
Oh, okay. So yeah, you can configure the lifetime of the token, and usually what we do is once you receive the token in the application, you can store the token in the secure enclave of the device, or if it is a browser, in the session storage, and then use it. But of course, you need to have an internet connection to reach out to the APIs, okay? But you can store the refresh token. The refresh token can last up to, I think, 90 days or something like that. And you can exchange the refresh token. So you don't need to have a continuous connection with external ID.
Okay, thank you.
Okay.
Saw in your diagrams you'd mentioned using conditional access to invoke MFA.
Yes.
But in your code, you were calling MFA from the code. I didn't see anything in there that was related to actually access. So I was wondering if you, in your lab, had a conditional access policy.
Yeah, let me show you. Let me show you my tenant. So first I need to remember where is this configured. But
I think it's under protection.
Yes. I'm trying to see. Conditional access. Okay. I'm using a cable also to get more speed, but I don't know.
The demo gods are here and present, yes.
So yes, and this is basically using the authentication context. So in the conditional access policy, you can define which authentication context you require. So the implementation is partially done in the web application, because you need to request an authentication context, and then you need to have a conditional access policy that says, when someone requests that authentication context, use an MFA method.
So the policy here is only defining what contexts are permitted or MFA
yes,
types.
exactly.
Okay. And
so I don't know why it's not loading, but let me show you. I can show you the code in the web application. Let me see. Here in program, I think it is. So let me see if this is big enough. But in this portion of the code, we are configuring the event to handle the redirection to the step-up parameters. So basically, when the application, the web application, because the API is telling this is a high-value transaction, remember the agent shared a link. When you click the link, then you go to a specific view, which is called step up. And this is the code that basically adds. This is also URL encode. So basically here, we are telling Entra that we need a token containing the ACRS claim with a specific value. So the implementation is partly done in the web application and the other part is in the tenant, okay? Let me try to load this again. I don't know what's happening. Did I answer your question?
Yeah, you did. I would have liked to see the policy, but that's fine.
Yeah, yeah, me too.
Thank you.
No problem.
Thank you. This is really great demo, great learning as well. I have one question. Is this let's say I have any external identity provider, let's say Okta or Ping. Is something we can secure it rather than using Entra, Microsoft Entra?
Can you repeat? I didn't hear you very well.
So let's say I have any external identity provider, let's say Okta or Ping.
Okay.
Is this something I can secure this API, any external identity provider, rather using Microsoft Entra?
So your question is, you have your API, but your API is protected by Okta or another provider.
Correct. Yes.
So the API needs to validate the token, right? So if your API can validate the token, an Entra token, it should work. I don't see any, I mean, for sure you won't be able, I mean, yes, you will be able to register the API in Entra, but the token validation needs to consider that the authority will be Entra external identities. I don't know, I really don't understand why you should do something like that.
Some of the enterprise level, they may not be using, Entra, correct? They might be using an external identity provider, let's say Okta or Ping identity as well, correct? So that scenario, how will protect the API?
Okay, but in that case,
yes,
you are going to federate Entra external identity with another identity provider, but the tokens will be all emitted by Entra. So your APIs will validate only tokens coming from Entra.
Okay.
Make sense?
Okay, got it.
Okay.
Yeah, thank you.
No problem. So I don't know what happened here, but let's try again. Okay, so yeah, go ahead.
So just suppose if this application was connecting to 2 agents in the Azure AI Foundry, so do we need 2 app registrations? Like in the demo you had an app registration for 1 agent API, right?
Yes, because basically you need to verify explicitly, right? So each agent will have its own application ID, and then you can give permissions to one agent to talk to a second agent. But I heard in the Satya keynote on Monday that there's going to be a new kind of object in Entra to handle these agent scenarios.
Yeah, that's why I was confused, because they mentioned that an agent will have an identity of its own.
Yes.
Is that same as this, or I mean, we do create.
I mean, this is the manual way to do it. Okay. Hopefully that will make this much more easier. Okay. So now I had to create 3 app registration, configure all the tokens, hopefully that will allow us to do this more in an easier way. Okay.
And just one on top of it, so if one agent talks to the other agent, will you have to do an overflow there as well to get the token?
Well, it depends. I don't know how the agent-to-agent communication will be, but if it's done through API calls, for sure you will need to exchange one token, because the token you will receive will have the scope for the first agent, and you need another token to call the API of the second agent. So the OVO flow will be the right flow to use. Okay. Okay. So I think we are almost at time. Thank you very much for joining. Please check out the repo. The repo will be open like for 2 months, and I will be replaying any issue, or and we can collaborate here in these repositories also. Thank you.